Assalamu alaikum. Welcome back to another very interesting video regarding differentiation. Today we will discuss derivation of x raised to power n. We will derive x raised to power n by ab initio method. So let's suppose y is equals to x raised to power n. As we know that in differentiation we write y is equals to f of x. So suppose this y, we replace it by f of x, which is equals to x raised to power n. Ab initio's method first rule says f x plus delta x, means add delta x in the value of x, and delta x is the small change in the value of x, which is equals to add delta x in the value of x on the other side also. So the second step was to find f of x plus delta x minus f of x. We are dealing with the case when n is positive integer. We will discuss two cases when n is a positive integer and when n is a negative integer. So this is a case when n is positive integer. This is equals to fx plus delta x is equals to x plus delta x raised to power n minus, and f of x is equals to x raised to power n. Now this step needs simplification. So let's do it. We have x plus delta x raised to power n minus xn. So we will simplify this term by binomial expansion, a plus b whole power n. So x raised to power n and delta x raised to power 0. We start the binomial expansion having the greatest power of this x and the lowest power of this second term, and in the last we get the smallest power of this first term and greatest power of this second term, plus nx n minus 1 and delta x power 1. Gradually these powers increases and this power decreases, plus n into n minus 1 over 2 factorial and delta x square up to so on, and in the last we get the greatest power of delta x, that is delta x power n, and this term become x raised to power 0, and anything which has the power 0 becomes 1. So we are left with delta x raised to power n. So we have expanded this term, let it close in a bracket, minus x raised to power n. Now this is x delta x raised to power 0, which means 1. So 1 multiplied by x raised to power n gives x raised to power n, and this is minus x to raised power n, so we can cancel out this term and we are left with nx n minus 1 delta x raised to power n means the same number, plus n into n minus 1 over 2 factorial delta x square plus delta x raised to power n. So now we can take delta x common from all these terms. Delta x nx n minus 1, this delta x has been taken common, plus n into n minus 1 over 2 factorial. Delta x is taken common, so we are left with delta x power 1, plus Out of these n's, 1 is taken common outside. So we are left with delta x raised to power n minus 1. Because out of these n, 1 is taken common. So delta x raised to power n minus 1. Now third step of ab initio method is to divide the term by delta x. Delta x, first write this term again, nx n minus 1 plus n minus 1 over 2 factorial delta x plus delta x n minus 1. Divide this whole term by delta x. Here we have is delta x which we have taken common from all the terms, and here we have delta x which we have divided according to ab initio's third rule. So we can cancel it out and we are left with this term. Now fourth step is to take limit of the third step, simplification. So applying limit on this term, so we will write this term as it is, plus n into n minus 1 over 2 factorial delta x plus delta x n minus 1. Now limit is that delta x is approaching to 0. This delta x will approach to 0. And all these terms, this term is delta x raised to power n minus 1. So delta x and delta x is approaching 0. So we are only left with this term, nx n minus 1. So initially we started that f of x, we were finding the derivative of f of x. So f dash x we got is nx n minus 1, or we can say that d over dx f of x. This means differential, this means derivative of f of x. So we can also write it as we are differentiating f of x with respect to x. F of x we have is x raised to power n. So it means d by dx x raised to power n is equals to nx n minus 1. This is the proof of power rule when n is a positive integer. Next we have a second case, y is equals to x raised to power n, where n is a negative integer. Let's suppose n is equals to minus m. This m is itself a positive integer, but we have put a negative sign. So n is equals to minus m. The question we have is y is equals to x raised to power n, or we can say f of x is equals to x raised to power n. But we have replaced n by minus m. So we will write f of x is equals to x raised to power minus m. When we have a negative power, we can write it as a positive power but replacing its position in the denominator like this. So f of x is equals to 1 over x raised to power m. Now first step we have is by ab initio method, f x plus delta x, which is equals to 1 over x plus delta x raised to power m. So we are done with the step 1. Step number 2 is f of x plus delta x minus f of x. So f of x plus delta x is equals to 1 over x plus delta x raised to power m minus 1 over f of x, which is equals to 1 over x raised to power m. Now taking LCM of this term, we have x raised to power m and x plus delta x whole power m. By the simple method to take LCM, we will get xm minus x plus delta x whole power m. Next we have delta x raised to power 1 plus m into m minus 1 over 2 factorial into delta x square up to so on, and in the last we will get x raised to power 0 and delta x will get the greatest power m. Now what will we do is, here we have is x raised to power m and this is x raised to power m multiplied by delta x raised to power 0. Delta x raised to power 0 means 1. So 1 multiplied by delta xm will give us xm. So xm will cancel out with this xm. Now we have 1 over xm x plus delta x whole power m. So next we have 1 over xm x plus delta x whole power m into, this is minus, and write all these terms, mx m minus 1 into delta x up to so on x raised to power 0 delta x raised to power m. So now can we take delta x common from all these terms? The last term is delta xm. Taking delta x common from all these terms, we have 1 over xm x plus delta x raised to power m into, this delta x is taken common, minus sign will come as it is. Now mx m minus 1, this delta x has been taken common, plus m into m minus 1 over 2 factorial, this delta x will become, this delta x square will become delta x, since one delta x has been taken common, plus out of these delta x raised to power m, 1 is taken common, so we are left with delta x raised to power m minus 1. So the next step we have is, this is a simplified step. The next step of ab initio method is to divide the term which is f of x plus delta x minus f of x. This is the answer of that term. Dividing that term by delta x. So if we divide this term by delta x, so what will come? 1 over delta x of the division, and this term will come as it is, delta x x plus delta x raised to power m minus delta x mx m minus 1 up to so on delta x m minus 1. So this delta x and this delta x will be cancelled out. So in the third step we divide the whole term by delta x. Delta x and delta x has been cancelled out and we are left with this term. Now the fourth step is to take limit of this term. So taking limit delta x approaching to 0. This term contains delta x in it and delta x is approaching to 0, so the whole term will cancel out. It will approach to 0. Here also this term delta x raised to power m minus 1, this is m minus 1, it will also approach to 0. So we are left with minus m, m minus 1 inside the bracket, and outside the bracket we have 1 over xm, and the expansion of this term tells us that x raised to power m will be left only. All other terms contain delta x in it, and since delta x is approaching to 0, so all other terms will vanish. So we are left with 1 over x raised to power m multiplication x raised to power m from this expansion, and here minus mx m minus 1. Okay. Now 1 over, this is xm and this is xm, and we know that when bases are same, powers are added. So x is a same power, base, so power will add 2m, and this minus mx raised to power m minus 1 will come as it is. Now minus m, and this is x raised to power m minus 1. Here it is in the Debian form. When it will move in the above the denominator, means in the numerator we will write x raised to power minus 2m. We discussed that minus m, bases are same, so powers are added. M minus 1 plus minus 2m. Minus m minus 2m is minus m and minus 1. As we said in the starting that n is equals to minus m. So replacing minus m with n. N raised to power, this minus m will replace by n minus 1. So the derivative of the function is nx n minus 1. The value of function we have is x raised to power n. So this is the derivative of x raised to power n. So we infer that the power rule is irrespective of positive and negative integers, because in both cases we have got the same answers. In the next video we will discuss exercise 2.1. So you can give your suggestions related to questions in the comment box. Thank you for watching my video. Hit a like button, subscribe and share.